So we're going to solve this rational inequality in 10.5 number 8. So because of the less than symbol, we're going to be having a part of the number line for the answer. As we look at this, we notice that x minus 2 is in the denominator, and that means part of our answer should be that x cannot be the number 2. So when we write out our number line, we'll want to make sure that on the number 2, we put an open circle. Because if x were 2, we'd be trying to divide by 0, which is not allowed. Division by 0 is undefined. So the way we solve these inequalities, we factor the numerator. So let's see, this numerator factors as x minus 3 times x plus 1. And then we get our key numbers that divide up the number line into pieces from these factors. So if the x minus 3 were 0, or the x plus 1 were 0, or if x minus 2 were 0, these are the numbers for x that divide our number line up. So when x is 3, or x is negative 1, or when x is 2, we divide our number line up into sections. So let's see, on the x is 3, we could mark that off here. And then the x is 2 is already marked off, and then x is negative 1, that's over here. That creates 3 sections of number line, actually more than 3. Section 1, section 2, section 3, section 4. 4 sections of number line. And each section of number line has numbers that make the whole inequality true or make the whole inequality false. So we just have to check each section. I'll make a little chart to keep track of the sections. From each section, we'll pick a test number, and we'll plug the test number into the factored form of the inequality. And what we want then is for the inequality to come out less than 0. So we're going to check and see, does that happen? So from the first section, over here I can pick any number to the left of negative 1. So maybe negative 2. I'll pick negative 2 and plug that in the inequality. So negative 2 minus 3, that's negative 5. Negative 2 plus 1 is negative 1. Negative 2 minus 2 is negative 4. So this would be 5 over negative 4, which is less than 0. That's true. So we want to include section 1 in our answer, because since the negative 2 made the inequality true, any number from the section 1 will make the inequality true. Now I'll go ahead and pick a number from section 2. So we're looking between negative 1 and 2. I can pick x is 0 for that. So in section 2, I'll pick x is 0, plug that into my inequality. I have negative 3 times 1 over negative 2, which is negative 3 over negative 2, which the negatives cancel, and you get positive 3 over 2. That is not less than 0. So we don't want to include section 2 in our answer because it makes the inequality false. So any number from section 2 would make the inequality false. And then we go on to the section 3. So section 3, I need a number between 2 and 3. I'll pick 2.5. If x were 2.5, I've had 2.5 minus 3 is negative 0.5. 2.5 plus 1 is 3.5. Then if we put in 2.5 in the denominator, 2.5 minus 2 is 0.5. Now I don't even care what the result is. I can see that it's negative because I have this single negative here. So I have a negative times a positive, which is negative, and a negative divided by a positive is negative. So the result is negative. Negative is less than 0. So whatever I get, it's going to be negative and thus less than 0. So I want that section included. One more section to check, section 4. I'll pick a number that lies to the right of 3. How about 5? So if x is 5, 5 minus 3 is 2. 5 plus 1 is 6. 5 minus 2 is 3. So I'm going to get 12 divided by 3, or 4, which is not less than 0. So as you're working this out, we checked each section to see if the numbers in there make the inequality true. We found that sections 1 and 3 should be included in the answer because they make the inequality true. We went through and actually found the numbers that you get, but really all you care about is being positive or negative. In this case, you want your result to come out negative. So you can just focus on the signs. So negative times negative is positive. Positive divided by negative is negative, which we saw. And if you want, you can just focus on signs and not the actual numbers that you get. Whichever way makes more sense to you. You're just checking each section of number line. All the numbers in each section either make the inequality true or they make the inequality false. So our answer then would be negative infinity up to the negative 1, union 2 to 3. We use the open circle because we had the less than symbol, but even if we had had less than or equal to, on the 2, we would have had to use an open circle. On the other points, if we had had a less than or equal to symbol, then we would have used a solid dot.